And so let's go ahead and look at the other bitwise operations. So first up, I'm going to delete a couple of these lines. And so I'm going to go ahead and look at the bitwise AND operation first. The bitwise AND operation is essentially going to compare whether or not the same position of bit is turned on for both values. And if it is, it's going to also do that. It's going to take that position and set the bit to be turned on in that position. Again, depending on whether or not the same bit is turned on for both values. And that might seem a bit confusing, so let's go ahead and see what that looks like visually. So I'm going to go ahead and show the version of data that's shifted left twice. And then I'm going to go ahead and show the bit set of the full operation. So what I'm going to do is I'm going to take data. I'm going to do the AND operation, bitwise AND. I'm going to put in parentheses data shifted left twice. I'm actually just going to end it right there. So let's go ahead and see what that looks like. And so, as we can see right here, this is the original version of data. This is data that was shifted after it was shifted left twice. And then this is the output of our full operation. And so the way you should read this is not from, again, left to right. As I stated previously, you want to look at what's being operated first. So first off, you will take data on the left, and you actually want to read from the right, because this is what's happening first. Data is shifted left twice, and so this is what that is. And then it's taking the bitwise AND operation to data, and then the remainder expression of what this looks like. And so in this case, because this is the only column where it has both ones turned on, it was only able to, or rather, it only evaluated this bit position to be turned on. In this case, because the original data value did not have this bit turned on, but it did not meet the expression's requirements for both positions to be turned on. And so that is why we only have this one bit that is turned on. Next, let's look at the bitwise OR operation. The bitwise OR operation is also commonly referred to as the bitwise assignment operation, because it will turn on the bit whenever it determines that another bit is turned on, regardless of whether or not it's present in both values. And so let's go ahead and see what that will look like in our example. So in this example, I'm going to use the pipe operator. This is the bitwise OR operator. And so let's go ahead and see what that will look like when we run this. And so as you can see, we now have 3 bits that are turned on in our final expression. And again, this is because anytime it determines that a bit is turned on, it will turn that on for the output expression as well. So even though we don't have a bit turned on right here for the regular data, but we do for data when it's shifted left right here, it will turn that on for our output expression here as well. And it does so here as well when the data that is shifted left does not have it, but the original data does. It will simply do that. It will simply turn the bit on for the output as well, and it does so for when both bits are turned on. And so now let's look at the bitwise XOR operator. The bitwise XOR operator is also referred to as the bitwise exclusive OR operator, and what its purpose is to turn on the bit that is exclusive to one of the expressions. And so what that will essentially mean is that if it determines that the bit in one position is turned on, but not for the other one, it will turn that one on in its output expression. And so if there are both expressions that have the same bit turned on in the same position, it won't turn that on because it's not exclusive. So let's go ahead and see what that will look like when we run it. And as you can see right here, because the bit in this position is turned on in the second expression, but not in the first, it did turn it on in its output expression. And because both values have this bit turned on, they're not exclusive, and so it was not able to turn this on again because it is not exclusive to the position. However, it is exclusive in the first expression, or rather the first value for this position to have its bit turned on, and not here. So it is exclusive, and so it was able to turn this bit on. The last bitwise operator I'll be going into is the bitwise complement operator. And this operator is actually a unary operator as well. What that means is that it only takes a value on one side. The rest of these operators have taken a value on both sides. What this means is that it takes a value on the left hand side and on the right hand side. But in this case, the bitwise complement operator will only take a value on the right hand side. So I'm going to go ahead and delete this line, and I'm going to go ahead and change the operator on this line to the bitwise complement operator. What that's going to look like is the little squiggly or tilde, the little tilde symbol right here. Let's go ahead and see what that looks like when we actually run it. And so what you can see here is that it does it turns on all the bits that are not turned on, and does not turn on the bits that are turned on for the original expression. It essentially just does what's called a bit flip. It flips all the bits to their opposite values, and so all the bits that are turned on right here or turned off right here, are then turned on in the output expression, and the bits that are turned on in the original value are then turned off in the output expression. And so again, this is a unary operator, which means that it does not take any value on the left, or not really the left, but just it doesn't take in two values to operate on. It only operates on one value at a time. And so let's look at a bit more complicated example using the concepts we talked about prior. And I know this may look a little bit scary, but trust me when I tell you it's not. It's just about taking bits and pieces of it and breaking it down into smaller, more easily readable sections. I will be taking a much closer look into everything that's happening here. So just bear with me while I explain just the general idea of what's going on, and then later we will break this down into much more smaller sort of bits and pieces. So first off, what we can read here from left to right is the bitwise complement operator. It's going to take everything that happens in here, and at the end of it, it's going to flip the bits from this expression. So all the zeros are going to turn into ones. All the ones are going to turn into zeros. So next, we have in this set of parentheses, we have data that's being assigned to the value, or that's being that has the bitwise or bitwise assignment operator towards the data value that's being shifted left twice. So it'll take data, it'll shift the bits left twice, and then whatever bits that has, as well as the bits in data, all those bits will be turned on. And then after all that happens, it will be compared to the bits that happen in this expression right here. The bits in this expression, it again starts with the data, our normal sort of bit set with data, and it'll perform a bitwise exclusive OR operation. But before the exclusive OR operation, the unary bitwise complement, or the bitwise bit flip operator, will flip the bits of data that after it's shifted right once. So the normal data value will be shifted right once, and then the bits will be flipped. And then after those bits are flipped, then we will perform the exclusive OR operation, which will take the normal data bits, and it will compare them to see what is exclusive, what bits are turned on for the normal data value, or what bits are only turned on for the bits that's in this data value, which ones are exclusive for those and not present in the other one, and then turn those bits on in the new expression. So after all of that, it's going to be compared to this expression right here through the bitwise AND. So whatever ones are turned on right here, and whichever ones are turned on right here, it's going to be returned with that. Otherwise, they're not going to be turned on. And then again, after all of that, the bits are going to be flipped. So let's go ahead and see what happens, or rather what all this is doing one at a time. Okay, here I have a much more broken down representation of what's going on. So here we can see we have the normal bit set or normal binary representation of data, which is 000, 001, 01. And then in the first place, over here to the left right here, we have the first expression going on right here. So data is being assigned to data shifted left twice. So right here, I've shown what that looks like when data is shifted left twice. So these bits right here are shifted left twice. So this bit is now right here. This bit has taken over for this spot right here. And so after all that, the bits are then assigned to a new expression depending on which of them is turned on. So even though this bit right here is turned on, but this one isn't, that doesn't matter because we're doing bitwise OR. So just one of the bits here has to be turned on for it to be assigned. And so you can see that right here, this one's assigned, this one is assigned because both of them are turned on, and then this one is assigned as well because this one is turned on. So that explains this section right here. So next we will talk about this section right here. And so right here, starting off, we have data being shifted right once. And so what that will look like is you'll just have a single bit turned on right here. And the reason why is because, again, as we talked about with bit shifting prior, this bit has no place to go. This is the least significant bit. It is the last bit in the bit set. And so it is being overwritten. And so then this bit will then take the place of the second most least significant bit right here. And so this is the only bit that will be remaining in this bit set. And then we have the bit flip that happens in the next line. So the bit that is right here is then turned off, and the rest of them are turned on. The ones turn, or the zeros turn into ones, and the one is turned into a 0. And so then after that, we have the bitwise exclusive OR operation. Remember, what this is going to do is it's going to see what is where are the ones that are exclusive to these two values right here. So the ones that are in data and the ones that are in this expression right here, rather right here, as long as those are exclusive, they will be turned on. And so we can see that right here. So the bits that are right here were exclusive to one of these values, and then the zeros are where ones did not line or did line up, and they were not exclusive. So lastly, we can see that this is the representation of the bitwise values in both of these, in sort of the last sort of the bigger sort of view of the expressions right here. So as you can see, this is the expression that was the output of the first sort of section right here. This section right here is the output of this expression right here. And so afterwards, when we perform the bitwise AND operation, which is kind of like the sort of middle of what's happening after these two expressions right here, we can see that after all of that, the one is the one right here is the only bit where both of these expressions have the same bit turned on. It's the bit in the same position for both of these expressions is turned on, and that's the only place where it happens. And so because that is the only place where it happens, it is the only bit that is turned on. And then lastly, to end it off, we then flip all the bits that have been turned on or turned off. And so all the zeros turn into 1, and then all the ones turn into 0. So I hope that was somewhat helpful in being able to read bitwise operations. And I hope that that's at least giving you a bit more of a useful way of breaking down reading bitwise operations.